Hello students, this is one of the interesting questions I got from somewhere. I don't exactly know the source of this question, but I found this interesting, so I thought that I would share this question with all of you. And you can pause the video here and try this question on your own. Uh, Now let's move forward towards the solution part of this question, right? Since in these kind of questions, we already know that we can apply conservation of mechanical energy, conservation of angular momentum, and things like that, right? So now let's assume the velocities at these positions where the distances are given, right? So let's say the velocity is v1 at position A and velocity v2 at position P, right? That is the perigee position. And also, let's take another position, another general position, when the distance of this planet is r from the sun. And at this particular instant, we can assume that the net velocity will have two components. One will be the radial velocity along this radius vector, and one perpendicular to it, that is the tangential vector, right? So we have taken the origin of the coordinate system at the sun here, and of course the radial component of the velocity will be actually inward or towards the sun at the given instant shown in the figure. But for the sake of simple convenience, or simple, you can say, the convention, we have taken it to be outward direction. It does not matter, right? So now what can we further say, right? Of course, we can apply conservation of angular momentum, since the net torque about the sun is going to be zero, because only gravitational force is there which is passing through the sun itself. So we can apply conservation of angular momentum, and that is going to be mass into the distance into the perpendicular velocity. Since mass is going to be same, I have not taken the mass here. So A times V1 equal to P times V2 equal to R times V tangential, right? So this is the first equation we have got. And another part, for the maximum approach velocity, right? So approach velocity is actually the radial velocity that is towards the sun, right? So with this velocity, tangential velocity, this planet is actually not approaching the sun, right? So approach is happening because of this VR, right? So when this VR is going to be the maximum, we can apply the condition of maxima minima. If VR is going to be maximum, that means we can say d by dt of VR is going to be equal to 0, since VR is maximum at this position, right? And VR is already basically the radial velocity. So we can say that d2r by dt square will be actually equal to 0. This will amount to be d2r by dt square. And if that is happening, my radial acceleration be actually equal to centripetal acceleration, right? Along the radial direction, you will have two kinds of acceleration, right? One away along the radial direction, that will be d2r by dt square, and also one part will be the centripetal, that is either omega square r or simply v tangential square by r, right? And since this part is actually equal to 0, only this part vt square by r is remaining, right? So basically the net acceleration towards this planet is going to be the centripetal acceleration, that is vt square by r. So we can just apply here the that we can think of that all the centripetal force, that is mv square by r, mv square or mv perpendicular square by r. This v perpendicular is basically the tangential velocity here. Don't get confused here. This is basically equal to vt, right? So mv perpendicular square by r is going to be the gravitational force, right? So we get the value of vt from here. Now what, we can also apply the conservation of mechanical energy, right? So at all the positions, the total mechanical energy is going to be same. So if I just take the apogee and perigee position, right? So I have written the equation for the apogee and perigee position, right? So here it is for the apogee position, here it is for the perigee position. From this part, and also from the first equation, using first and this equation, we get this third equation where v2 is coming out to be this much, right? Now we can just use the equation number 1, equation number 2, and equation number 3, all of that. And I'm sure you guys can do that on your own. Using all these three equations, we will be getting R equal to 2AB by AP by, rather it should have been AP. There is a slight mistake. Let me correct that. 2AP by A plus P, that is coming out to be 40,000 kilometer, right? So if you got any benefit from this question, please share it with your friends. Thank you.